Right, welcome to Unit 2, Lesson 8, Comparing Relationships with Equations. So we're going to start with the warm-up. Do you see, what do you notice and what do you wonder? So it says, do you notice a pattern? What predictions can you make about future rectangles in the set if your pattern continues? So I want you to write down one thing you notice and one thing you wonder. Pause the video now. All right, welcome back. So a couple of things that you could have noticed is that the width is increasing by 3 each time. So our width is increasing by 3 each time. Something else you could have noticed is that the height is increasing by 1 each time. All right, a couple of things that you could have wondered was by how much does the area increase each time? You could have wondered, what will the rectangle, which rectangle will have a width of 10? So these are just some things that you could have noticed or you could have wondered, not necessarily what you did or didn't notice or wonder. So let's turn the page from 127 now over to 128. So we're looking at activity 8.2, more conversions. So the other day you worked with converting meters, centimeters, and millimeters. Here we are going to convert some more units. Number 1 says use the equation F equals 9/5 C plus 32, where F represents degrees Fahrenheit and C represents degrees Celsius to complete the table. So we're going to use this equation, and all we're filling in for is C and solving. So right here, our C is 20. So we have 9/5 20 plus 32. So we've got to figure out what is 9/5 of 20. So let's multiply that. 9/5 times 20 over 1 plus 32. So 9 times 20, well, what's 9 times 2? 18, add a 0. We have 180. 5 times 1 is over 5 plus 32. So we've got to simplify that. 180 divided by 5. So we've got to figure out how many times does 180 go into 5? Well, 5 goes into 18 3 times. For 15, we subtract. We have 3 left over. Bring down a 0. 5 goes into 36 times. So we have 36 plus 32. And when we add those together, we end up with 68. So we're going to put 68 in this first spot. I'm going to switch colors for the next one. So now our C is going to be equal to 4. So we're going to have 9/5 times 4 plus 32. So it's 9/5 times 4 over 1 plus 32. Pause the video now and complete the rest of this equation. All right, welcome back, and let's check and see how you did. So 9 times 4 is going to give us 36. We're going to have 36 over 5, and we can simplify that again. 36, 5 goes in 7 times with 1 left over. So then 5 goes into 10 twice. We have 7.2. So 7.2 plus 32, and that is going to give us 39.2. And we're going to do the very last one in a different color. So we have 175. So we're going to do 9/5, 175 plus 32. So 9 times 175 over 1 plus 32. So let's multiply. I'm going to use my calculator for this one. So 9 times 175 is going to give us 1,575. We're going to divide that by 5. Again, you can use your calculator. And we're going to end up with 315. Don't forget that you need to add your 32. So we're going to have 315 plus 32, which will give us 347. So all we had to do here was fill in what was representative of C into the equation and then solve to figure out what F would be. All right, let's go down to number 2. It says use the equation C equals 2 54/100 of N, where C represents the length in centimeters and N represents the length in inches. So N is inches. We want to find the one that's inches and put N. C is going to be the one that represents centimeters. And we have our equation of C equals 2 54/100 of N. So now we've got to complete the table to find C. So we have 2 54. We're going to multiply that by 10. So we have 2.54 times 10. You're going to end up with 1 times 4, 1 times 5, 1 times 2. Your decimal point comes down here. And we're going to have 25 4/10. Try the next one on your own. Pause the video now. All right, welcome back. Let's check it. So we would have our C is equal to 2 54/100 times 8, or we can write it this way as in 2.54 times 8. So 8 times 4 is 24, or nope, 8 times 3 is 24, 8 times 4 is 32. 8 times 5 is 40, plus 3 is 43. 8 times 2 is 16, plus 4 is 20. So we have 2 decimal points. This would be 20 and, oops, made a boo-boo. What did I do? Oh no, I was right, 20 and 32/100. 20 and 32/100. Switch colors. We have a fraction here, but this is 1/2, so it's an easy one to convert. So we can do 2.54 times 2 1/2. So 5 times 4 is 20, carry the 2. 5 times 5 is 25, plus 2 is 27. And then 5 times 2 is 10, plus 2 is 12. So now we've got to put our placeholder. 2 times 4 is 8. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. And now we can add this up, zeros, 7 and 8. That's going to give us 15. Carry the 1, we end up with 3. 1, 2, 5, 6. Now we've got to be careful here. We've got to count how many decimal spaces we have. Which we have 3 of. How did they get that? So in this case, we have 1, 2, 3. which gives us 6 and, why doesn't that work? According to the textbook, it is 8.89. I don't know what mistake I made.
Does that mean you have to restart?
So we made a boo-boo here. We made this 2.5 and it's supposed to be 3.5. So we're gonna go over here. We're gonna do 2.54 times 3.5. So this top row is gonna stay the same where it's gonna be 1270 because the 5 didn't change. But then we have 3 times 4, which is 12. 3 times 5, which is 15, plus 1 is going to give us 16. 3 times 2, which is 6, plus 1 is 7. So now let's add that together. We have 2 zeros. That gives us 9, 8, 8. And then again, we have 3 decimal places. So make sure you're using the right number when you're converting from fractions to decimals. So this one over here is wrong. So now it wants to know, are these proportional relationships? Explain why or why not. What do you think? Well, I think this first one doesn't because we are adding something extra to it. So the temperature one is a no. Because we're adding 32 to it. But the second one, I think it does because we're only multiplying by the 1 and we're not adding anything to it. So the inches to centimeters one does because it's not having anything added to it. All right, so we're going to skip page 129 and we're just going to go right to page 130. So this first one, it says here are 6 different equations. Predict which of these equations represent a proportional relationship. So you're just going to look and decide which ones of these do you think are going to represent a proportional relationship and circle them. So pause the video and take a moment to do that. All right, so let's check your answers. We're going to complete each table using the equation that's representative of that relationship. So here we have y equals 4 plus x. So if x is 2, we're going to add 4 to it. So 4 plus 2 is 6. And we're going to have y over x, which would be 6 over 2. Or if we were to simplify that, 3. So now we would have 4 plus 3, which gives us 7. And then y over x again would be 7 over 3. Now we have 4. So 4 plus 4 gives us 8. And this would be 8/3. Now our last one is 5. So y equals 4 plus 5, which gives us 9. And we have 9/3, which again gives us, that's thirds. This one's fourths, which would be 2. This one's fifths. So is that one proportional? No, it wouldn't be because this one isn't going at a constant rate. So this first one is not proportional. Let's look at the next one, y equals 4x. So y equals 4x, our x is 2, 4 times 2 is 8, and this one would be 8 over 2, which is equal to 4. I want you to go ahead and fill in the rest of this table and then come back. All right, welcome back. So you should have gotten 12, 16, 20. And each time it would have been 12 over 3, which is equal to 4, 16 over 4, which is equal to 4, and 20 over 5, which is also equal to 4. So this one would be a constant proportional relationship. So because it's not increasing, but being multiplied by the same number each time, and our slope doesn't change. So that one is definitely a proportional relationship. Let's look at this one. Y equals 4 divided by x. So let's look at y. We have 2, 4 divided by 2 is going to give us 2. So in this case, it would be 1, or 2 over 2 is equal to 1. Now we have 4 over x. So our x is 3, so this one would just be 4/3. Now we would do 4 over 4. 4 over 4 is the same thing as 1. So this would be 1 over 4. So this would be 4/9. 1/4. All right, and now it would be 4 over x. This time x is 5, so it would be 4/5. And our slope would be 4/25. So this one would not be a proportional relationship. All right, let's look at this one. We have y equals x over 4. So this time our x is 2 over 4. Our next one would be 3. This would be 3/4, 4/4, 5/4. And each time it's increasing by 1/4. So this one would be a proportional relationship. All right, let's look at this one. So we have y equals 4 to the power of x. So when we're looking at that, it would be like 4 times 4 twice if this was cubed. If it's squared, if it's cubed, it would be 4 times 4 times 4. If it's to the power of 4, it would be 4 times 4 times 4 times 4. I'm just going to give you the answers for this one because this one can be a little tricky. So it would be 16, 64, 256, and then 1024. And we would have 8, 21 1/3, 64, 204, and 4/5. And it doesn't follow the pattern like this one does or this one does. So this one would not be a proportional relationship. So if it's got a square or to the power of something like that next to it after the constant, it's probably not going to be a proportional relationship. So let's look at this one. Now we have y equals x to the power of 4. So 2 to the power of 4 would be 2 times 2 times 2 times 2, which is 16. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is going to be 256. And 5 to the power of 4 is going to be 625. And again, we have 8, 27, 64, and 125. So this one is also not a proportional relationship. So we only had 2 that ended up being a proportional relationship. Y equals 4x and y equals x over 4. So this is going to be an opinion piece based on what you circled originally. So do these results change your answer to the first question? Explain your reasoning. So pause the video to answer that question. All right, so what do the equations of proportional relationships have in common? So if we're looking at this one and this one, what do they have in common? Well, there's a couple of things. One is that they're written in the form of y equals kx, which is our formula that we're using. They do not contain any exponents or addition operations. And we could probably go so far as to say subtraction. And they do not involve dividing by the x. So those are just 3 things that equations of proportional relationships have in common. All right, that is it for lesson 8. I will see you next time.